All right, we're here for lab number 8, which is the identification of a petroleum hydrocarbon. You're going to learn 2 new techniques, which are boiling point and refractive index. We've already done the melting point of a solid, but if you have a liquid, well, you're going to have to find the boiling point of that liquid. You can still use that physical property to identify a compound. We're going to triple up in this lab. What we're going to do is the scenario this time is we've been hired by a group to determine the possibility of a compound called thrust, which is supposedly a gasoline additive, can actually be a engine performance additive that really would work. And in this case, what we're looking for is, does it have a octane rating of above 87? If it has an octane rating of above 87, then it could be, but probably wouldn't still be in the amounts that they listed on the label, be a, quote, engine improvement. But your job is to, looking at a group of compounds which are listed for you on page 94 in the textbook, you're going to determine, based on that, does the compound have an octane rating of above 87? If it does, then you can make that claim. So I'll have to give you some information about compounds, but really the most of the material you're going to need is off of page 96 in the book. And 3 things are listed about the compounds, and they are the boiling point, the density, and something called the refractive index. Now, you don't know about anything about the refractive index yet, or you may have learned about it in class, or you may have learned about it in some other chemistry class or physics class. But you do know about boiling point and you do know about density. So the goal is we're going to take all 3 of those pieces of data and then try to identify which one of the unknown compounds that you have. So you should have one of those compounds from page 96. Well, you will have one of those compounds from page 96 because that's the ones that I chose the unknowns from. And then you can refer back to page 94 to check the claim that it has an octane rating high enough to use. So refractive index is essentially that physics term of when different materials, light goes through them, light gets bent differently. And so every substance has a refractive index based upon what it is. So we have a device called the Abbey refractometer, and there is actually I have a video for you from it. If you look at this website while you're looking at this page, you could also use this one. And this one's kind of a stop action of what's going on with it. And this one, the reason I picked it, this one looks pretty much like ours. The refractometer, when you look into the refractometer, you're going to see there's a big knob on the side. I'm not going to go through that part, all this for you. I'm going to show you how to read the scale because the videos show you how to do all of this. But there's 2 major things you want to see. You want to be able to see this. You see it here. You want to get this situation. You want to put this right in the middle of the screen. And when you do, you'll flip a switch and this scale will come up. And if you look at this scale, the scale is the hardest thing to read. If you'll notice, here's 1.460 and here's 1.470. So this is 1.461, 1.462, 1.463, 1.464, 1.465. Notice that the refractometer automatically reads for you first 3 digits. And what you'll do is read the 4th digit based upon where the line is, and you'll estimate the 5th digit. So you can get 5 decimal places past the decimal point on the refractive index. So this one is between the 1.460 and the 1.461, and there's little half marks in there. It's slightly past the half mark. So we're going to call that 1.4606 because it's between the 0 and the 1, but over the half. So 1.4606. Okay, so there's all the information will tell you how to clean it and everything like that. So that'll be one of your pieces of data. Second piece of data will be density. You will use a volumetric pipette. I would recommend probably like a 3 to 5 milliliter volumetric pipette. I'm not sure what we have in the back room, so I'll get some out. And very simply, you'll put a precise amount, and I'll put a video on the website on how to read a volumetric pipette. Put a precise amount. We will use volumetric pipettes that only measure one volume. Fill it up to the line, release that amount into a tared bottle, and the amount of liquid that comes out should be your amount, and then your mass divided by your volume, since you'll know the volume from the volumetric pipette, should give you your density. Now the third thing is going to be the boiling point, and we're going to do the boiling point in the melting point machine. We have you know what our little capillary tubes look like. It's unbelievable, but we can take that capillary tube, and I have capillary tubes that are even smaller than that. We're going to turn those upside down. So what you're going to do is put liquid into the capillary tube, and you'll drop this smaller capillary tube in there upside down. And what will happen will be, you will see, it's really hard to read this thing, and it's very difficult. You need to look up the microscale boiling point technique in the back. And that is, it will tell you how to read this. But essentially what's going to happen is there's going to be bubbles expelled from this thing. And you will notice that the bell will start to shoot out bubbles. And you'll notice a bunch of bubbles. That'll probably be air in the beginning. And then when your material begins to boil, it will actually start to put a steady stream of bubbles out of the bottom of this inner tube. When you see that, you're going to turn off the melting point machine and let it cool on its own. At that point, you will see the liquid out here get sucked back up into this inner tube. When you see the liquid get sucked back up into the inner tube, what you want to do is turn the machine back on slowly. And when you see the first bubble come out of the tube, you want to record that temperature. So you'll have a higher end temperature when you see the bubbles coming out of the tube, and you'll have your lower end of your boiling point range when you see the first bubble get blown out of the tube. So that will give you the boiling point based upon that. That's the microscale boiling point technique. So really all we're doing this time is doing 3 physical properties of a substance: the boiling point, the refractive index, and the density. Match them up in a table real simply. It's a very easy lab. And make a determination from that. Is my chemical one that has an octane rating above 87? If it does, then in theory, it could be a good gasoline additive. So that's all you're going to need from me for this. Make sure you read the microscale boiling point technique in the back of the book. Amazing, there's no videos on it. It's almost impossible to record a video of it. There are videos on the other 2 techniques. See you Thursday.